Welcome again, grade 8 students. This is me, Teacher Christine, your science teacher for this week. Before we proceed with our new lesson, let's have first a short review on what we have discussed last week. You were able to learn that some animals, including bats and dolphins, use echolocation to navigate and find food. You were able to learn also that people use ultrasound technologies such as sonar and ultrasound imaging to observe things that they cannot see directly. You were able to learn also that an electromagnetic wave is made up of vibrating electric and magnetic fields that move through space or some medium at the speed of light. Last week, we were able to discuss also that two different models are needed to explain the behavior of electromagnetic waves. A wave model best explains many of the behaviors, but a particle model best explains others. So, are you ready with our new lesson? That's great! For this week, we will be discussing Lesson 2 of Chapter 9, Waves of the Electromagnetic Spectrum. At the end of the lesson, you have to attain the following objectives. First, explain how electromagnetic waves are alike and how are they different. And lastly, describe the waves that make up the electromagnetic spectrum. At the end of the lesson, you have to know the applications of the following words: electromagnetic spectrum, radio waves, microwaves, radar, infrared rays, thermogram, visible light, ultraviolet rays, X-rays, and gamma rays. So before we proceed with our new lesson, I want you to prepare the following materials with you. First, you have your textbook. The next one, you have your pen. And lastly, your highlighter. I want you to open your textbook on page 300 and read my planet diary entitled, "Hey, where did it go?" I want you to answer the question that follows as well. I know you were able to read already my planet diary, but what is a cloak? A cloak that is shown in this picture is a sleeveless outdoor overgarment that hangs loosely from the shoulders. How would you use an invisibility cloak? Of course, if you want to sneak out of your room. And why you might get caught if you were wearing the invisibility cloak in the text. My parent could see through the microwave shield, so they could see me. How do electromagnetic waves compare? Can you imagine trying to take a photo with a radio or heating your food with X-rays? Light, radio waves, and X-rays are all electromagnetic waves, but each has properties that make it more useful for some purposes than others. All electromagnetic waves travel at the same speed in a vacuum, but they have different wavelengths and different frequencies. We have said a while ago that all electromagnetic waves travel at the same speed in a vacuum. What is a vacuum? A vacuum, as shown in this picture, is a space that contains no air or other gas. So I want you to remember this one. All electromagnetic waves travel at the same speed in a vacuum, but they have different wavelengths and different frequencies. So what are examples of electromagnetic waves? Visible light is the first example. It is the only range of wavelength your eyes can see. From the word itself, visible means you can see it. Another example is radio waves. Your radio detects radio waves, which have much longer wavelengths than visible light. Another example is an X-ray. On the other hand, it has shorter wavelengths than visible light. For waves in any medium, as the wavelength decreases, the frequency increases. So, what is the relationship? Excellent. They are inversely proportional. Waves with the longest wavelength have the lowest frequencies. Waves with the shortest wavelengths have the highest frequencies. The higher the frequency of a wave, the higher its energy. So, in this picture, you will see that wavelength and frequency are inversely proportional, while frequency and energy are directly proportional to each other. So I want you to answer the following questions before we proceed with the next concept. First question, how are electromagnetic waves alike? Very good. All electromagnetic waves travel at the same speed in a vacuum. Second question, in what ways are some electromagnetic waves different from others? Very good. Electromagnetic waves have different wavelengths and different frequencies. What makes up the electromagnetic spectrum? There are many different types of electromagnetic waves. The complete range of electromagnetic waves placed in order of increasing frequency is called electromagnetic spectrum, as shown in this picture. The electromagnetic spectrum is made up of radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and lastly, gamma rays. So the first kind of electromagnetic wave is the radio waves. These are the electromagnetic waves with the longest wavelengths and lowest frequencies. Radio waves are used in broadcasting to carry signals for radio programs. A broadcast station sends out radio waves at certain frequencies. Your radio picks up the radio waves and converts them into an electrical signal. The electrical signal is then converted into sound. The second electromagnetic wave is called microwaves. Microwaves have shorter wavelengths and higher frequencies than radio waves. When you think about microwaves, you probably think of microwave ovens that is used for cooking and heating food. But microwaves have many other uses, including cellular phone communication and radar. What is a radar? Radar stands for radio detection and ranging. Radar is a system that uses reflected microwave to detect objects and measure their distance and speed. To measure distance, a radar device sends out microwaves that reflect off an object. The time it takes for the reflected waves to return is used to calculate the object's distance. The next electromagnetic wave is called infrared rays. If you turn on an electric stove burner, you can feel it warm up before the heating element starts to glow. The invisible heat you feel is infrared radiation, or simply infrared rays. Infrared rays are electromagnetic waves with a wavelength shorter than those of microwaves. They have higher frequencies and therefore more energy than microwaves. Because you can feel the energy of infrared rays as heat, these rays are often called heat rays. Heat lamps have bulbs that give off mainly infrared rays. They are used to keep things warm, such as food in cafeteria or young animals in an incubator as shown in this picture. Most objects give off some infrared rays. Warmer objects give off infrared rays with more energy and higher frequencies than cooler objects. An infrared camera uses infrared rays instead of visible light to take pictures, called thermograms. A thermogram is an image that shows regions of different temperatures in different colors, as shown in these pictures. It is also used to see objects in the dark, and firefighters use infrared cameras to locate fire victims inside a dark or smoky building. I want you to look on the picture on page 304, the thermogram. So what kind of wave are used to make thermogram? Very good. They use infrared waves. According to the scale, what is the warmest part of the image? Excellent. The palms of the hand has the hottest or the warmest part. What do you think the person is holding? Yes, the person is holding a large spider or a tarantula. The next electromagnetic wave is called visible light. They make up only a small part of the electromagnetic spectrum. Visible light waves have shorter wavelengths and higher frequencies than infrared rays. Visible light that appears white is actually a mixture of many colors. Recall that light waves bend or refract when they enter a new medium. So, when white light passes through raindrops, a rainbow can result, as shown in this picture. The next electromagnetic wave is called ultraviolet rays. Electromagnetic waves with wavelengths just shorter than those of visible light are called ultraviolet rays. Ultraviolet rays have higher frequencies than visible light, so they carry more energy. The energy of ultraviolet rays can damage or kill living cells. For example, too much exposure to ultraviolet rays can burn your skin and over time may cause skin cancer. However, small doses of ultraviolet rays are useful. They cause skin cells to produce vitamin D, which is needed for healthy bones and teeth. I know you are very familiar with the next electromagnetic wave. Yes, you are right. That is X-ray. Electromagnetic waves with wavelengths just shorter than those of ultraviolet rays are called X-rays. Their frequency are just a little higher than ultraviolet rays. Because of their high frequencies, X-rays carry more energy than ultraviolet rays and can penetrate most matter. Dense matter such as bone or lead absorbs X-rays so they do not pass through. Therefore, X-rays are used to make images of bones and teeth. However, too much exposure to X-rays can cause cancer. X-rays can also be used in industry and engineering. Engineers can use an X-ray image of a steel or concrete structure to find cracks, as shown in the picture on the right. The last electromagnetic wave is called gamma rays. Electromagnetic waves with the shortest wavelengths and highest frequency are called gamma rays. Since they have the greatest amount of energy, gamma rays are the most penetrating of electromagnetic waves. Because of their penetrating ability, these rays are used to examine the body's internal structures. A patient can be injected with a fluid that emits gamma rays. Then, a gamma ray detector can form an image of the inside of the body. Some radioactive substances and certain nuclear reactions produce gamma rays. Some objects in space emit bursts of gamma rays also. However, these rays are blocked by Earth's atmosphere. Astronomers think that explosions of distant stars produce these gamma rays. I hope you were able to learn something from this lesson. So to wrap up everything, first, all electromagnetic waves travel at the same speed in a vacuum, but they have different wavelengths and different frequencies. And lastly, the electromagnetic spectrum is made up of radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. So that's it for today. Thank you so much for listening. Again, this is Teacher Christine. I will see you again next week.